Assalamu alaikum. Welcome, my dear students. Our lesson today is the second lesson on Unit 2 for Grade 8. Our lesson today is about the wave nature of light. Wave nature of light. Okay? Open your booklet, page 84. Firstly, we want to talk about what's meant by light. Last lesson we have talked about the sound. It is the external factor affecting the human ear causing sense of hearing, but light is the external factor affecting the human eye causing sense of vision. Okay? Light is electromagnetic waves. Who know what's meant by electromagnetic waves? Electromagnetic waves, doesn't need a medium to transfer. It can transfer in vacuum or in space. Doesn't require the presence of a medium. Okay? The speed of light or the velocity of light reaches to 300 million kilometers per second, or equal 3 times 10 power positive 8 meter per second. Okay? The speed of light, if you want to talk about the speed of light or the velocity of light, the velocity of anything, it is a distance covered by this thing in unit time or in second. Okay? So the speed of light is the distance covered by light in 1 second. In 1 second. Okay? But light has very large components or many components. The first part is the visible light. It has a range of wavelengths from 380 to 700 nanometers. Okay? What's meant by visible light? It is one of the components of the electromagnetic spectrum of wavelengths range between 380 to 700 nanometers. Okay? Look at this chart. Is the long wavelengths, it has the smallest energy like the infrared rays, okay, but the shortest wavelengths related to or relative to it has higher energy, okay, like the ultraviolet rays or gamma rays or x-rays in our cosmic space, that like the emitted from the sun. Okay. Now we have to know what's meant by light. It is the external factor affecting the human eye causing sense of vision. Speed of light, huh? Who know? Okay, very good, excellent. Speed of light is the distance covered by light in 1 second or unit time. Okay. Now we'll talk about the analysis of light or the splitting of light. All of us know, as we have studied in grade 5, I think, that the light travels in a straight line and the main source of light is the sun. Okay. The white light or the sunlight consists of 7 spectrum colors. 7 spectrum colors. So, if we want to know the analysis or the splitting of white light or sunlight, we must to get a glass prism like this, okay, triangular glass prism. If the sunlight falls in one of each side, the other side will split this light into 7 spectrum colors. 7 spectrum colors. It has an order. The first one is the red and orange, yellow, green, blue, indigo, violet. The first spectrum colors is the light. It has the lowest energy. It has the lowest deviation. It is the nearest to the apex of the glass prism. Okay? And vice versa. The violet has the highest energy, the highest deviation. It is the nearest one to the glass bead. Okay? Look at this chart. Red one has lowest division, it is closest to the prism apex, lowest frequency, longest wavelength. In lesson 1 in this unit, we have talked about the relation between frequency and wavelength. It has inverse relation. So, longest wavelength, it means lowest frequency or the smallest frequency. Okay? Violet, it has highest energy and highest division, highest frequency, shortest wavelength. Okay? Right. Who can compare between the green and orange color or orange light? Which one of them has highest energy? Which one of them has longest wavelength? Firstly, the green has largest energy. Okay? Largest energy. It has greatest division. Okay? But orange has low frequency and longest wavelength. Longest wavelength. Okay? The second part of this lesson is talk about the energy of light. The energy of light, it means we have a relation in scientist called Max Planck. He said that the energy of light related to the frequency, and there is a direct relation between the energy of light and the frequency. Okay, so we can say that the energy of light or the photon energy, the elementary particles of light, it is called photon. It is a small part of light or a small particle, elementary particle of light called photon. It is a new word for us. It is a photon. Okay? Photon energy or the light energy equal Planck's constant times photon frequency. Times what? Photon frequency. Okay? The energy of light equal Planck's constant times frequency. Okay? There is a direct relation. It is symbolized by a straight line passing by the origin. In the vertical axis, we have the energy symbolized by E capital, and the frequency on the horizontal axis, there is a direct relation. Okay? As the frequency increase, the energy of light increase. Okay? Which one of these two light has the greatest energy? Look at this. Waves, the red photon and the violet one. Which one of them has the greatest frequency? It's very clear to us that the violet has the greatest frequency. Violet has the greatest frequency, so it has the greatest energy. So it has a greatest energy than the red one. Okay? Right. What is the uses of light in our daily life? Light, it can be used in spotlight, in lighting our houses and streets, stand lamps, okay, ornamented lamps to bring happiness, and decorating lamps in our house or office, okay. We have a small problem here. The speed of light equal distance covered by light per unit time. The measuring unit of speed of light is meter per second. Meter per second. Speed of light is 3 times 10 power positive 8 meter per second. Okay. Try to solve this problem. Find the distance. It is very easy. Find the distance covered by light through 2 minutes. Through 2 minutes. Take care from 2 minutes. If the velocity of light equals 3 times 10 power positive 8 meter per second. Okay? We said before that light is electromagnetic waves, and it is transverse or longitudinal. Excellent, student. Is transverse, electromagnetic and transverse waves. Okay? As we said before, light travel in a straight line. Light travels in two different mediums. The first one is transparent medium, like the air. You can see the board, you can see your book, your pen, your phone. Okay? So air is transparent medium which allow most of light to pass through it. Allow most of light to pass through it. Right. The second medium, which is translucent medium or semi-transparent medium, it is like the frosted glass or a tissue paper Third one, it is an opaque. Okay? The first one, it is a medium that allow most of light to pass through it. Second one, it is a medium that allow some of light or part of light to transfer through it. So you can see the object less clearly than the transparent medium. Huh? Who can define what's meant by opaque medium? Opaque medium, like the door, like the wood, like the iron, like the milk, like the black honey, that doesn't allow light to pass through it. It is opaque. Okay? So we have three different medium. The first one is transparent medium that allow most of light to pass through it. And the second one is translucent medium or semi-transparent medium which allow some of light to pass through it. Some only or part of light. Okay? We have a small question here. Although water is transparent medium, we can't see the fish at the bottom of the river, because as the thickness of the transparent medium increase, if you have a transparent plastic or a transparent piece of glass, you can see the title of the object. If you put this transparent glass on the title of book, you can see the title of your book. But if you increase the number of glass sheet, you can't see the title of your book. What happened? Because by increasing the thickness of transparent medium or transparent piece of glass, the amount of light passes through it decreases. As you increase the thickness of the transparent medium, the amount of light passes through it decreases until it looks like an opaque one. Okay? Okay. I am waiting for your question in our official group on Facebook. Cartoon is an opaque, milk is an opaque medium because it doesn't allow light to pass through it. Okay? The fourth properties of light travel in straight line. Light travel in straight line. It means it can't pass in a curved line or a zigzag line. Okay? We have a small activity here. If you have 4 pieces of carton, okay, and you put the source of light in front of the first one, and make 4 holes in the same or a certain point in the same 4 pieces of carton. What will happen? Light travel through the 4 pieces of carton and reaches to the second part or the second side. What happens if you move the piece of carton, which is the second one or the third one, for example B or C, okay? So the hole doesn't passes in front or in straight line. The light can't pass to reach the second part or the second side. Means that for our observation or our conclusion, the light can't pass in curved line or a zigzag line, and the light pass in straight line. And the light can be directed. Light can be directed. Okay? Light intensity. What's meant by light intensity? Last lesson we have talked about the sound intensity. There is an inverse relation between the sound intensity and the square of the distance between sound source and certain point. Okay? Also, light intensity have the same law. It is the inverse relation between the distance with the square of distance between the source of light and the screen. Source of light and the screen. Okay? We have two photos here. A boy stands with a flashlight in a distance 1 meter from the wall. The light intensity in the first is greatest than the second one. All of us know these two pictures. Okay? The light intensity in the first one, which has a small distance equal 1 meter, and the large distance equal 2 meter, it has inverse relation. As the distance increases, the light intensity decreases. So all of us know there is inverse relation. Okay? The light intensity is inversely proportional to the square of distance between the light source and certain point or the white screen. Okay, where the light can be received. Okay, the inverse square law of light, the light intensity of a surface is inverse relation or inversely proportional to the square of distance between the source of light and the screen. Okay, the light intensity is the quantity of light falling perpendicular on unit area in 1 second. In 1 second. Okay. At the end of our lesson, just reminding, our lesson today, it was about the wave nature of light. We know what's meant by light and the speed of light and analysis of light, or the splitting of light into 7 spectrum colors and the different medium related to light. Okay? I hope this is useful for you. Thanks for you.